Think about your software for just a second. The source code, it's literally its DNA. Every single function, every variable, it all builds this living, breathing application that your entire business relies on. But what if there's a genetic flaw hidden deep inside? Today in this explainer, we're going to explore how secure code review acts as a high-powered microscope for your software's DNA, and why catching these hidden flaws early is the ultimate high-stakes game for modern business resilience. So here is our roadmap for this explainer. 1. The anatomy of code vulnerabilities. 2. Defining secure code review. 3. The 7-step review process. And 4. The ROI of shifting left. Let's get right into it. Section 1, Anatomy of Code Vulnerabilities. Let's establish exactly how these genetic flaws create massive business risks. All right, so when most of us think about cyber threats, we picture, a hacker in a hoodie aggressively bashing against a firewall. But actually, the most dangerous threats are usually internal. They're born right there in the development phase. Think about hard-coded credentials. It is shockingly common for developers to just leave API keys or passwords or even backdoor access right there in the code for quick testing, and then they totally forget to take them out. Then you've got insecure coding patterns. This happens when teams unknowingly use outdated functions or vulnerable libraries. Hackers already have the blueprints to exploit those, so they're just waiting for you to use them. And third, logic errors. We're not talking about a simple typo here. This is a fundamental flaw in how the app handles permissions. Imagine one standard user just casually viewing another user's highly sensitive private data. It's a total nightmare. So what are the real-world consequences? Well, we aren't just talking about a technical hiccup. We are talking about devastating business outcomes. If an attacker stumbles on those hard-coded credentials, bam, instant compromise. They literally have the master keys to your entire cloud and database infrastructure. Then there are zero-day exploits. Attackers can leverage those known bad coding patterns to crash your application entirely, or just quietly siphon off data before you even realize a flaw exists. And those logic errors, they lead to massive data leaks, which instantly triggers severe GDPR or SOC 2 compliance violations. We're talking heavy lawsuits, massive regulatory fines, and honestly, a total loss of user trust. The stakes, they absolutely could not be higher. Section 2, Defining Secure Code Review. Let's pivot from these terrifying risks and look at the actual solution. Secure code review. It's exactly what it sounds like, but highly specialized. It's a line-by-line examination of an application's raw source code designed to find hidden vulnerabilities that are completely invisible during standard execution. What I really love about this concept is just how proactive it is. Think about traditional penetration testing. It's kind of like checking the locks on a house after it's already been built, right? You're testing a live, running app. Secure code review, on the other hand, is like inspecting the raw blueprints before the concrete is even poured. By shifting your security to these early stages and looking at the raw code directly, you find those deep architectural flaws without risking any disruption to a live application. What's really fascinating here is that to get this right, you need a true hybrid approach. It's not just one person staring at millions of lines of code, and it's definitely not just a piece of software doing it all alone. First, you have the robotic efficiency of automated SAST, scanning. That's static application security testing. These automated tools do the heavy lifting, deep scanning massive repositories to instantly catch those common patterns like SQL injections or those hard-coded secrets we just talked about. But you absolutely need manual expert review to go with it. Why? Because automated tools just don't understand business context. You need human security architects to manually verify complex business logic and dig up those hidden contextual flaws that a scanner simply cannot see. Section 3, the 7-step review process. Let's break down the exact methodology used to build these bulletproof applications from day one. Okay, let's look at how this works in practice. Cyber Ambassador uses what's called a shift-left methodology. Basically, that means pushing security to the absolute earliest stages of development. Step 1 is preparation and scope. This is where the security team identifies the exact languages and the critical modules of your specific code base. Step 2 is threat modeling. They analyze the app's architecture to track exactly where the most sensitive data flows. You got to know it needs the fiercest protection, right? Then step 3 is automated SAST scanning. This is where they deploy industry-leading tools to rapidly find those high-volume, low-hanging vulnerabilities across the entire repository. But as we just learned, they don't stop at the automated scan. Step 4 is the manual deep dive. The experts manually audit high-risk sections of the code, things like user authentication or payment processing, because that's exactly where those devastating logic errors like to hide. Step 5 is false positive filtering. Let me tell you, this is an absolute lifesaver. They strip out all the noise, providing only real actionable risks so your dev team isn't wasting time chasing ghosts. Step 6 is comprehensive reporting. You get a precise line-by-line report showing exactly where the flaw is, and more importantly, how to rewrite it securely. And finally, step 7, the developer walkthrough. They don't just toss a report over the fence, they actually consult directly with your developers to ensure the patches are done right and teach them how to write safer code moving forward. It builds a long-term culture of security. Now, you might be thinking about your own tech stack right now, wondering, does this actually apply to us? The short answer is absolutely yes. Whether you're building in modern web languages like PHP, Java, Python, or Node.js, or you're creating mobile apps with Swift or React Native, this process totally applies. It even extends to auditing smart contracts for complex blockchain and Web3 applications. And on the flip side, it works perfectly for hardening older legacy C and C++ code bases against modern threats. Basically, it's a complete screening of your tech stack's DNA, right down to the root, no matter what language it happens to be written in. Section 4, the ROI of shifting left. Let's shift gears from the technical how-to and focus on the massive business value. Here is a statistic that will blow your mind. Fixing a bug deep in the code during that early development phase is up to 30 times cheaper than trying to patch it after a disastrous breach has already happened in a live environment. Seriously, 30 times. When you start factoring in the exorbitant costs of incident response, legal fees, compliance fines, and desperately trying to win back lost customer trust, well, shifting your security left isn't just a technical best practice anymore, it is an absolutely critical financial strategy for your entire business. Beyond those massive cost savings, you're locking in some serious core business benefits. First off, you get secure SDLC integration. That means embedding these reviews directly into your DevOps pipeline to guarantee continuous protection with every single software update you push. You also get compliance assurance. This process ensures you are actually meeting the incredibly strict secure coding requirements for heavy-hitting regulations. Think PCI DSS 4.0, HIPAA, and ISO 27001. Plus, because you're reviewing raw code and not a live environment, there is literally zero risk to your production uptime, no disruptions whatsoever. And lastly, you gain the Cyber Ambassador seal. This gives your clients totally provable confidence that your software was built from the ground up with a security-first mindset. Which brings us to the end of this explainer. I want to leave you with a question to really chew on. Is your software truly secure from the inside out? You know, it is so easy for businesses to focus all their time and money on firewalls and external network perimeters, but the true absolute foundation of your security, it lies deep within your source code. I really hope this explainer gave you a powerful new perspective on your software's DNA and why inspecting those blueprints line by line is literally the best possible way to stop risks before they ever become real. Thanks so much for learning with me today, and I'll catch you next time.